Use the random sample below to compute each of the following: A, the sample mean, B, the sample standard deviation, and C, an 80% confidence interval. So for parts A and B we can do together, we can refer back to our formula sheet. So we're going to need the formula for mean, sum x over n, and for standard deviation from earlier in the course. So we had a computation formula for standard deviation. This is the one we used, and we're going to need to apply each of these here to get mean and standard deviation. And again, these formulas will be available to you on the final. So we'll plug in mean is sum x over n, and standard deviation of the sample is square root sum x squared minus parentheses sum x close parentheses squared over n, still under the square root all divided by n minus 1. So to do these first two computations in A and B, we're going to need to make a chart, x and x squared. So for x, we have, our values are, well, 10, 12, 15, and 20. If we square them, we'll get 100, 144, 225, and 400. Next we add. The sum of x is going to be 57. And on my calculator, the sum of x squared turns out to be 869. And you should confirm this on yours. So for part A, the sample mean is going to be sum x over n is going to be 57. The value of little n is the sample size, which in this case is 1, 2, 3, 4 data values. So if we take 57 divided by 4, I come up with 14.25 for my sample mean. For sample standard deviation, we have to plug into our other formula. So we'll take our giant square root and we'll do sum x squared. And again, this one doesn't have parentheses, so order of operations says you do exponents next. And so we need to plug in the sum from where we had squared first. So in other words, the first thing we put into our formula is the second column, total, which is 869. Now we'll subtract the sum of x squared. Notice this does have parentheses. You do inside the parentheses first. In other words, we should put the total where we had added first. In other words, second, we put the total from the first column, 57. And then square it over n, which again is 4. The whole thing still under the square root divided by n minus 1, which is 3. Now, if you get this, then the rest is just carefully plugging into your calculator. Some calculators can do this all at once. What I would do if you're unsure is to take the 57 and square it and then divide by 4. After you get that answer, then you can subtract that off of 869. You can confirm that when you do that, you get an answer of 56.75 on top over 3. If you divide next, we should divide before taking the square root. Divide 56.75 by 3, then do the square root. We'll get an answer of approximately, and I'm going to round to 4 decimal places here just to be safe, because we're going to use our answer in part C of 4.3493. So our sample standard deviation is 4.3493. Now that we have our mean and standard deviation, we can get our confidence interval. So again, we're going to look to our formula sheet, and for confidence intervals, we have 2 options here. So we're dealing with x bar minus e, x bar plus e, because we want a confidence interval for mu. We have our x bar, that was our value of 14.25. We just need to know what our E is. Is it going to be ZC or TC? Well, this is the part you have to be sure of. Do we have a standard deviation of the population, or do we have an unknown standard deviation of the population? Well, in our problem, you remember, we had to actually calculate S. So we don't know the population standard deviation. We have the sample. So therefore, we're going to use the value of E with a T value on it. So we're going to use the t-table. It's TCS over root n, n minus 1 degrees of freedom. Let's write this down. So our confidence interval is x bar, which is our 14.25 minus E, x bar plus E. E is equal to TC, or in this case t.80, times S standard deviation, which we got as 4.3493 divided by root n. N is 4. So we just need to look up t.80 on our t-table with n minus 1 degrees of freedom. So that would be 3 degrees of freedom. So our confidence, C for confidence, is 0.80. And if we go down to 3 degrees of freedom, then we get the value of 1.638. Plug this in, and we get our answer. 1.638 multiplied by 4.3493 divided by square root of 4, which we might as well put as 2. All of this, if we throw it into our calculator, carefully work that out, is approximately 3.56. So let's take our x bar, which again was 14.25 minus 3.56, and 14.25 plus 3.56. And again, I go to my calculator, and I finally answer is 10.69, 17.81. And again, the interpretation of this is we are 80% confident, based on our sample of 4 data values, that the true population mean is going to be between the values of 10.69 and 17.81.